distribution. So let's start. If you like, then like. If you like, then subscribe this channel. Like, then subscribe this channel. It is very important to get knowledge of random variables for statistics. So I will this video. I hope you like this video. So let's start. If we consider a fair coin, itself, we consider a coin which is tossed twice. A coin which is tossed twice. So what are the sample space? It is tossed twice. So what can be its sample space? There are four outcomes it can have. One, that it have both head, or head tail, means one head in two outcomes, and at last we have both the tails. There are four maximum number of outcomes possible after having a tossed a coin tossed twice fairly. So there are four outcomes possible. If we consider that number of heads will be denoted by numerical numbers, number of heads will be denoted by numbers, by real numbers, number of heads. And how it can be number of heads? So if you have two heads, if we have two heads denoted by a number, we are taking, this is 2. One head is denoted by 1, and no head is denoted by 0. No head denoted by 0. One head is denoted by 1, and no head denoted by 0. Then this numerical representation actually gives us to generate random variable sense. So there we will get the sense of random variables. Now, if we take if we wish to represent it through a random variable, which can take three values. One is 0, 0 no heads, either one head or two heads. So this is the sense of random variable. Now, if we wish to know the probability of x, so how we can represent? I am giving you in another page. If x are 0 means no head, 0 means no head, 1 means one head, and 2 means two head, then probability distribution of x when its value is 0, then it will be no heads occur one times, two head occurs one time out of 4 outcomes. So its probability distribution is 1 by 4. If we will take p probability of one head occur two times. So there are 2 outcomes out of 4 outcomes. So this will be 2 by 4 means 1 by 2. And at last, if the probability distribution we take x taking value 2, then there are two heads possible in one outcome. So there are one by four. Out of four outcomes, there are one outcome of two heads. So now, if we add up, then total probability of X distribution, X random variable distribution, X are taking small x taking values 0, 1, 2. If you add 1 by 4, 2 by 4, and 1 by 4, you will get just 1. So it is a mandatory condition that after probability distribution, you must have the total probability distribution uh, equal to 1. So I am giving another example to clear it. Take a dice, consider a dice. Consider a dice. A dice has six faces. Consider a dice. It has six faces. So the faces are maybe 1, 2, 3, 4, 5, and 6. So these are the numbers written in the faces 1, 2, 3, 4, 5, 6. I am taking random variables. This is 100. This is 101. These are rational numbers given to these spaces. 102, 103, 104, 105. So if a dice is thrown twice, it is thrown twice. Thrown twice, it will be hard to calculate. I am just again taking the dice is thrown once times. This is thrown once times. 1. Then all the faces have probability just 1 by 6. There are sample space 6 outcomes possible. This is there are 1, 2, 3. These are the faces. Can be any anyone can be the outcome in in one single throw. So if we calculate the probability distribution, I have given the rest number 100, 101, 102, 103, 104, 105. If we wish to know the probability distribution, then we have to take x equal to x can be 100, 101, 102, 103, 104, 105. If we wish to know 104, then what will be its probability distribution? 104 underscore coordination is just one time it can be. 5 can be in one throw, can be just one time. So this is 1 by 6. There are 6 outcomes, 1 by 6. In this way, if you want to know probability distribution of x equal to 101, then what is the chances of the phase 101? There are the phase 2 will appear just one throw just one times. So there are only one chance. So 1 by 6. If we throw two coins, two dices, if we throw two dices, then there will be 36 outcomes. Till we use to calculate 32 outcomes, 36 outcomes. Two dices if rolled or thrown, then there will be 36 outcomes. And if are numbered by a random variable x are varying from 1 to 36. 1 to 36. All the reals are denoted by 1 to 36. Now we used to know that both the faces have two, just only two. So yeah, there will be a huge table. You have to calculate 1, 2, 3, 4, 5, 6. I'm just sketching to make understood. This is interesting. 1, 2, 3, 4, 5, and 6. Put another pen. This is 1, 2, 3, 4, 5, and sketching one more. This will be 6. This will be 6. And here 1, 2, 3, 4, 5, and one more. This will be 6. So we are using, there are 36 outcomes. All the grids are the outcomes. So there are 36 grids. So if you wish to know, and all are given by 1 to 36. This is 1 we are putting. The random numbers are given. This is 1. This is 1. This is 2. This is 3. In this way, this is 4, 5, 6, 7, 8, 9, 10, 12, then 13, 14. In this way, at last we will get 40. At last we will get 36. So this way, if we mark by random variables, real numbers, and make a random variable a function of these outcomes, then if we wish to know that both the faces of two dices have 2 2, so 2 2 have just this face 8. So we have to write down the probability of, we used to know two faces of the two dices will be 2. So it is marked by 8. So x will take the value 8, and we have to understood that we have to understand that it is the probability of two faces on the two dices. So this is just only, this can occur just only one times, 1 by 36 outcomes. If we know, if we wish to know that the numbers can be 1 or 2, in any one dice can be 1 or 2. So maybe 1 1, maybe 1 1, 1 2, 2 1, 2 1, and 2 2. So there are 4 outcomes. So this is denoted by just only one single outcome, 8. If we wish to know this incident, this is another incident, that here I have taken 1 1 1 2 2 1 2 2. So 4 outcomes. So if we wish to create a random variable, then we have to clear about the incidents, what we will we wish to take the incidence. Here we have taken the phases of just 2 2. So this is the yeah, x equal to will take the value 8, and there will be one outcome out of 36. And if we take this, then it will be x can take values, four values. This is 1, 2, 7, and 8. Four values x can take, and there will be outcomes 4 by 36. So this is the probability. If we will multiply 4, then it will be 1 by 9. So this is the probability of x taking value 1 to 7 8. In this way, random variables and the its probability distribution uh, are described. I hope you like this video. If you like, then like, share with your friends, and subscribe this channel to get such kind of videos. Thanks for